So in this video, we're going to take a look at how to assign loads and load combinations to the spherical tank. We're going to take a look at how to fix errors, modeling errors, and then we'll also look at how to design these supports and review the results, and then pass the support reactions to the foundation design engineers. So in here we have these load cases created. We're going to go in and create another one. Go to loads and active independent load cases, and we're going to create a new load case called self-weight. This is going to actually allow us to create a number of load cases like point loads, member loads, and so on. But really, we really want GT STRUDL to calculate it based on the density of the steel that we've assigned and the properties that we've assigned. So we'll use this last option. Now, the axis of gravity is in the y direction. So we are going to apply the self-weight in the y. If we say generate loads, you will see the self-weight loading in the graphics. Now we'll take a look at how to generate load combinations. For that, we're going to go in and click on this form load option. And here I'm going to create two load combinations. One is going to be 1.4 times dead load and plus 1.6 times pressure loading. And the other one is going to be 1.6 times the dead load plus the hydrostatic loading multiplied by 1.6, okay? So we type in 101, then we type in 1.4 times dead load plus 1.6 times the pressure loading, store that. Then 102, we're just going to create 1.4 times dead load plus 1.6 times hydrostatic loading. Now, in practice, you don't want to do this one by one because you might have 100 load combinations, let's say. So you may want to use a seed file in order to do this. This is just a very simple example that I'm creating. So let's just do it manually in this case. So a seed file is basically a GTI file that has all your loads and load combinations, so you don't have to type them up like I'm doing here, okay? So let's go in 1.6 for the hydrostatic loading also. And this way we have created two load combinations successfully. And we'll just click on OK and finalize those by clicking on yes. Now, once this load combination has been created, now we could go in and assign support conditions, okay? So in here, I'm just going to go in and create fixed support conditions just to make it simple. We're just going to go into supports and we'll just say we want to create the supports by fencing around. Now, note that I've accidentally created a support at an unknown location because something was selected before. I'll show you how to fix that. First, reset all the selections, okay? Next, we can go to the mode toolbar and use this fencing option, but also what you could do is you could select the nodes first. Okay, here, that's what I'm going to do now. Just select the nodes first, then click on create supports, and it should create the supports for you, okay? So you don't have to use this mode toolbar to assign supports. Now let's get rid of that support that was accidentally assigned there. And for that, we'll just go to edit, joint data, and here we can go to supports and releases, or you can go to type, okay? Let's take a look at both the options. First, we'll just go in and select all the node points, okay? And we want all of them to be released, okay, or with no supports. So we can control that using the type option, and here there's this option called free. And once we say done, it'll basically take off that support that was assigned accidentally, okay? And we'll just reset the selection. Now, there are some problems with this model, and I'm going to talk about that using, in a few minutes. But just to warn you that this tank was created using the wizard, and in the process of creating the elements at the top and the bottom, we have created some elements with an odd aspect ratio. Now, GT Strudel will warn you about that, but you can still proceed with those warning messages, and you can control that using the check consistency command also. Now, I'm going to copy and paste that command in the command mode. So that's why you could run the analysis right from GT menu if you like, but I'm going to go into the command mode just to show you the warning messages that GT Strudel is going to come up with, okay? So here is how you run the analysis. If you wanted to do that, you can do that, and it'll show you the same error messages, or sorry, the warning messages that are going to pop up. Let's just close this graphics and run the analysis from GT Shell, okay? So I'm going to use the 64-bit multi-core solver, and here are all the warning messages. Let's go back to GT menu. I think I have another problem here. I should have assigned, I probably didn't assign the supports properly. I'm going to create the supports once again. Let's just select the node points and create supports. And here you should see the fixed supports icon, okay? Let's close this, save this file, and then rerun the analysis using that 64-bit solver. Now we have another problem. Okay, the modeling error is that we have 8 distinct structures. Now that is because we copied that command 8 times, okay? And when we copied it, maybe there was a slight difference in the node point coordinates of the sphere and the column end points. So there were duplication of node points, okay? So now to merge those node points, you can go to check command and duplication of nodes, and you just give a tolerance, and here are those duplicate nodes, okay? So we can just delete all those node points to merge them. Again, we can go back to GT Shell, and this time you should see that the analysis should run properly, okay? Of course, you get the the warning messages. We can then go into results. Now, let's see the deform shape. We can animate the deform shape. This is one of the self-weight loading that you're seeing, but we can go in and look at any of these loadings, okay? You can control it using this dialog box, or you can also control it using the control that you see, the combo box at the top left-hand side corner. There's too many entities right now, so I'm just going to turn off the labeling so you can see the deflected shapes clearly. Now we can also see stress contours. I'm just going to stop the animation first. Let's go to results, finite element results, and contours. Here we can just select the contour option, and you can select any of the contours that you want to see. For example, bending stresses, you want to see Von Mises stresses, okay, and so on. But we also want to go in and design the supporting frame, right, or the steel members. For that, we can go to Design, Parameters, and here I'm going to pick the AIC code. You can select any code that GT STRUDL supports. All members, click on OK, click on Done. Then we're going to check these members. We're going to go to Design, Check. In this case, I'm going to select all the loadings. FXFYFZ, MXMYMZ. I'm going to also check these members at 3 different locations. And if I click on OK, we can see a text output of what happened, okay? The ones with the asterisk actually failed, so I know that some members have failed, okay? Now let's see graphically which members failed, okay? So we can go to Results, Steel, Code Check, and select members. It'll actually show you that some members failed. It looks like all the bracing members failed because of, let's say, slenderness. So the stress ratios are low. And if you see the code check values, the stress code check values, they're well below 0.64, right? So I'm just going to assume that the structure is okay right now. And now I want to pass the support reactions to the foundation design engineer. Now, for the foundation design engineer, there's 2 things that are required, So they need to know the location of the base plates. They also need to know the reactions on the base plates, okay? So they can design the base plates and they can also design the pedestals for this tank, and they can design the flexible mat foundation for it also if required, okay? So let's go and see this new feature inside GT STRUDL 41, which allows you to first select your support node points. I'm just going to draw these, a fence around the support node points, and then go to the datasheet option, okay? If I go to create modeling using datasheets, joints, here it'll show me a spreadsheet. Okay, it went to my other screen, so I'm just going to drag that spreadsheet from my other screen to this screen. And here, there's a new command. It's not available in the older versions. This is only GT STRUDL 41 specific command. So we can go to current selection, show selected joints. And it actually shows you what joints have been selected. You can select those joints and copy them to Excel. And you can send that Excel to your foundation design engineer, who will know the XYZ coordinate of your base plate. Okay, so just copy and paste. Next, we're going to do this for the support reactions. Okay, so for support reactions, you can go in and again, we can see results in the graphics. Okay, first I'm going to show you the support reactions, joint reactions in the graphics. So here we see the reaction forces. Now, these need to be applied to the foundation. So the foundation design engineer needs to reverse the signs of these loadings. Okay, so if you go to results, data sheets, joint reactions, that'll actually pop up the joint reactions data sheet. You can copy the entire spreadsheet if you like, with the header like we did before with the coordinates. But what will happen is it'll actually show you all the primary loadings as well. Okay, so in this case, you just want to pass, let's say, the concrete design load combinations. Okay, let's say in this case it's lowercase 101 and lowercase 102, okay, combined, or you can just say lowercase 101 only. Copy that, go to Excel, paste it, okay, with the header, and you can do it one by one, okay, and just give all the controlling load cases for concrete design to the foundation design engineer so that they can now design this concrete foundation. We'll cover that in the next video.